Okay, so here's the video for section 4.4, proving triangles congruent using side, 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 side angle, side. So section 4.3 was all about congruent polygon, or specifically triangles, but congruent polygons in general. So now we're going to talk about proving triangles congruent using two specific methods. So yeah, so if you recall, we've proved triangles are congruent using the definition of congruence. Now the definition of congruence states we have to prove all pairs of sides are congruent and all pairs of corresponding angles are congruent. So with this, we're going to shorten it up, make it a little bit easier work. So instead of proving 3 pairs of sides and 3 pairs of angles, we'll prove really just a few things. So the first method is called the side, side, side congruence postulate. And how that works is if you can prove that 3 sides of two pairs of triangles, okay, so if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. But more importantly, if you can prove that 3 sides correspond and are congruent, 3 pairs of sides, excuse me, then you got 2 congruent triangles. So I don't have to do anything with angles here, just prove we have pairs of sides congruent. Okay. And it makes our work a lot easier to do. So instead of proving 3 pairs of sides and 3 pairs of angles, just 3 pairs of sides. So we'll just jump into a proof because I think that kind of is the best way to go about it. So yeah, we got triangle QUD. Try to prove it's congruent to triangle ADU. So QUD, ADU. Given that QU is congruent to AD, QD is congruent to AU. Okay. All right, so here we go. Oops, wrong button. No, wrong. Ah, there we go. So the first thing we do when we're doing these proofs, before we even bother doing like statements and reasons and everything, is we look at the drawing and we try to see if we can figure out a way to prove we have some congruent triangles in there. And again, we only have one method right now. It's just side, side, side. That's it. So the question is really, can we prove that all 3 pairs of sides are congruent? Well, the first 2 pairs are easy. We got QU is congruent to AD, so those are marked. We've also got QD is congruent to AU. Those 2 sides are marked. So what we need to do is try to figure out, is there a way to prove the third pair of sides are congruent? Well, hopefully you'll see that, hey, wait, UD and those are the third pair of sides. It's itself. So I can say that these 2 are congruent to each other by the reflexive property. Okay, we haven't used that for a while, but that's our third pair of sides. UD is congruent to itself. Okay. And that's it. We got our 3 pairs of sides. So whenever I do these proofs here, in class at least, a lot of times I do this. I split up the given. QU is congruent to AD, given. 2 QD is congruent to AU, given. And here's why. Off to the side for myself, I write out side, side. And then I have a third pair of sides that UD is congruent to itself by the reflexive property. Okay. And there we have side, side, side. And that's, again, right now, it's the only way we have besides proving all the pairs of angles are also congruent. But this is easier, just side, 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 it's taken care of. So now that I've gotten side, 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 I can say triangle QUD is congruent to triangle ADU. Sorry, I ran out of space there. By side, side, side. So again, that might be a little weird right now, but it's going to get a lot easier as we do more and more of these. We'll spend a lot of time in class sorting through this, but that's what's going to kind of work as well. Okay, we have a property, postulate in this case technically, to prove 2 triangles congruent. It's side, side, side. So that's what our method is. Hey, can we show some sides are congruent? And one of the things to pick up on that you'll just have to get used to seeing is if the 2 triangles share a side, you've got a reflexive property, so you've got a pair of sides congruent. All right, the next way to prove that 2 triangles are congruent is using side angle side. Okay, now this one's a little more complicated to see and maybe even feel like it's using it, but it really in the end is just as easy as side, side, side. So we have 2 pairs of sides and an included angle of one triangle are congruent to 2 sides in the included angle of a second triangle, then the triangles are congruent. The big thing to define here is included angle. And the included angle is angle B and angle E. And what an included angle is is an angle between two sides. In this case, the side pairs sides that are congruent. Pairs that are congruent. Okay. So you literally have a side, then an angle, then a side. Side, then an angle, then a side. And if you could show you have that, then you have two congruent triangles. Okay. So here's the next example. These two triangles are congruent by side, angle, side. You've got your sides, PO, NO. That's one pair. PO, NO. Your other pair of sides are QO, MO. So we've got side, side. Okay, and so if we were looking through our methods of doing this, we would say, okay, we've got side, 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 and side, angle, side. So we can see we can still use side, angle, side, because we have our two sides, or we could do side, side, side. The question is, can we prove that a third pair of sides is congruent, or a pair of angles between is congruent? And although it looks like, and it is, MN is congruent to PQ, I don't have a theorem about that. But what I do have is I have an old theorem that says, hey, if two angles are formed by intersecting lines, which MQ and PN are, and they're opposite each other, those two angles are congruent. And that's because those two angles, angle MON and angle QOP, are vertical angles. Okay. All right. So we do have side, angle, side here. That's what we're going to have. So we're not going to have side, side, side. Marking that out. We have sides. I'm sorry. Oh, wrong one. Mr. Moyer. Disappointment abounds. We don't have side, side, side. We have side, angle, side, because our pair of angles. That doesn't work, does it? Our pair of angles that are congruent are angles MON and QOP. Okay, now look at a quick proof that uses side, angle, side. So we're going to write a two-column proof that is, well, this is from a different problem. So we're going to make a two-column proof to show that triangle ABG is congruent to triangle CGB if ABG and CGB are congruent, and AB is congruent to CG. So we're going to figure out, how do we know how to prove this congruent? Okay, so again, the first thing you should do, besides writing statements and reasons, and writing your given, I'm going to start with AB is congruent to CG, because that's a side pair, and then angle ABG is congruent to angle CGB. Both those are given. Okay. I've got sine and angle. So the next thing I do is figure out an angle, or a side that I have congruent. Well, again, mark in the drawing. AB is congruent to CG. Angle ABG is congruent to angle CGB. So we can see side, angle, side, angle. The question is, what's missing side? Well, hopefully we would catch BG is congruent to BG because they overlap and they share the same side, and that's the reflexive property. I can't write all of a sudden. Okay. So for triangle ABG is congruent to triangle CGB by side, angle, side. Okay, sorry for the weird edit there. I hit a button on accident. So for tomorrow, your homework's going to be these four triangles. Okay, how do we know they're congruent? You know, side, 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 or side, angle, side, and then we'll discuss what your reasons were. Okay, so if you have any questions, come in obviously before school. We can talk through anything. If not, I'll see you in class tomorrow.